right, section 6.4, factoring trinomials, the AC method. Well, I'd like to tell you that we're going to learn something new, but the book finally caught up with the way that I enjoy teaching factoring, and so we're going to continue doing it the way that I've shown you so far. Question number 1, find the pair of integers whose product and sum are given. So we're going to go do our x. The product is 48, and the sum is 14. So factors of 48, 1 and 48, 2 and 24. Will 3 go into there? Yes, it will go in 16 times. 4 will go in there 12 times. Let's see, 5, 6, and 8. And that's it. All right, so all of those are factors of 48. If you multiply them together, you get 48. Now, 48 is positive, which means the signs here and here have to be the same. And 14 is positive, so they both have to be positive. 6 plus 8 is 14. So the factors, the integers, are 6 and 8. Same game for question 2. Their product is negative 12, and their sum is 1. Because the product is negative, we need one of them to be negative and the other to be positive. So factors of 12, 1 and 12, 2 and 6, 3 and 4. Okay, we need to add those numbers together, knowing that one of them needs to be positive, one needs to be negative, and we need to get 1. If we did negative 3 plus 4, we would get 1. So the numbers are going to be negative 3 and positive 4. All right, question 3, factor the trinomial using the AC method. Okay, first thing I noticed, there's no GCF to pull out, no greatest common factor. It is a trinomial, and the leading coefficient is not 1. So when I do my x, I need factors of 8. So 8 goes up top. That will add up to negative 1. Okay, now the top number is positive, which means the signs have to be the same. The bottom is negative, so they both have to be negative. Factors of 8, 1 and 8, 2 and 4. That's it. So they both have to be negative. Negative 1 minus 8 is negative 9. That won't work. Negative 2 minus 4 is negative 6. That won't work. So guess what? This is prime. We don't have to go any farther because we couldn't find two factors that added up to negative 1. Number 4. Let's see, it's a trinomial. The leading coefficient is not 1. There is no GCF. So this is my next step. 2 times negative 3 is negative 6. 5 goes down below. Since I have a negative 6, one of them has to be positive, one has to be negative. Factors of 6, 1 and 6, 2 and 3. If I do negative 1 plus 6, I get 5. So negative 1 plus 6. All right, because this is not a 1 leading coefficient, I have to go factor by grouping. So I need to rewrite, and instead of writing plus 5m, I'm going to write plus 6m minus 1m. And then I also have to write minus 3. Now remember, last section, instead of trial and error, this is what I taught you to do. Okay, factoring the first two terms and the last two terms by grouping. First two terms, I can pull out a 2m. I'm left with m plus 3. The second two terms, I can pull out a negative 1, and I would be left with m plus 3. Now, if I pull out an m plus 3 from both terms, m plus 3 here, m plus 3 there. I'm left with 2m minus 1. All right, number 5. There's no GCF. I'm going to do 36 up top. And notice that this is a 1. These are easy ones. Negative 12 down below. Okay, factors of 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9. 6 and 6. 36 is positive, which means the signs have to be the same. The 12 is negative, so they both have to be negative numbers down here. If I do negative 6 minus 6, I get negative 12. Okay, I told you that this was an easy one because if this is a 1, I can write down my factor straight from my big X. K minus 6 times K minus 6. You're finished. Okay, number 6, back to the trinomial. There is not a GCF. I do notice that this is 7s squared, and I notice that this is 4 squared. That's going to come into play in just a minute. I'll show you what I mean. But let's say we didn't recognize that. So we're going to go do 49 times 16 and get 784. Boy, that's a big number. And then 56 is going to go down below. All right. I don't want to go do all of those. 56. 784 divided by, how about 28? Ooh, that's a perfect square. Okay. Here we go. 28 and 28. How did I do that? It's all because of the perfect square thing. I divided this number by 2. Let me show you what I saw. If I do positive 28 on both of them, I have 49s squared plus 28s plus 28s plus 16. I can factor out a 7s, and I have s plus 4. And here I can factor out a 4, and I'm left with, let's see, 7s plus 4. Oh, sorry. Hold on. I made a huge mistake. I didn't factor out correctly. Factor out a 7s from the first one. What's left? Not just s, but 7s plus 4. Okay, plus. Now factor out a 4, and I'm left with 7s plus 4. I noticed that I was not correct because these two didn't match, but now they do. So if I pull out 7s plus 4, I'm left with 7s plus 4. Now I told you in the beginning, I noticed that this one was squared and this one was squared. And look what happened. My answer was 7s plus 4 times 7s plus 4, so that's just squared. You should recognize that. If you see let's see how I want to do it. A plus B squared is a squared plus 2ab plus b squared. You should recognize that, and that's exactly the form that we had here. Okay, let's do another one. Number 7. I need to write it in the right form first. 7z squared plus 18z minus 9. The number up top is negative 63. The number on the bottom is 18. 63, 1 and 63, 3 and 21, and that's what we need. We can stop. Okay, the number up top is negative, so one's negative, one's positive. If I do positive 21, negative 3, that adds up to 18. So negative 3, positive 21. I'm going to rewrite 7z squared minus 3z plus 21z minus 9. And then group. The first two, if I factor out a z, I'm left with 7z minus 3. The second two, if I factor out a positive 3, I'm left with 7z minus 3. So my factors are 7z minus 3 times z plus 3. Number 8. I don't like the negative in front of the k squared. So I'm going to factor a negative 1 out. I'm left with 49k squared minus 7k minus 2. So in my x, 49 times negative 2 is negative 98. And down below I have negative 7. So factors of 98. 1 and 98. 2 and 49. 3 won't go in. Let's see, 98 divided by 4. Nope. Won't. 5 won't. 6 won't. Oh, 7 and 14. And that's what we need. Okay, top number is negative. So one of them is going to be negative. One's going to be positive. If I do positive 7 minus 14, I get negative 7. So negative 14, positive 7. I'm going to leave my negative 1 out to the side. Don't forget about him. Now I'm going to write 49k squared minus 14k plus 7k minus 2. From the first two terms, I know I can pull out a 7 and a k. I'd be left with 7k minus 2. I can't pull anything out of the second group, so I'm just going to put a plus 1 out there. So my factors are 7k minus 2 times 7k plus 1. And don't forget this negative 1 out front. So here's my answer. Okay, question 9. Factor the higher degree polynomial. You'll notice that the first term is an x to the 4th, and the second is an x squared. Okay, we're going to pretend like we see this, 2x squared minus x minus 10. If that's what we saw, how would we factor that? We would go 2 times negative 10 is negative 20, with negative 1 down below. Since this is a negative 20, one's going to be negative, one's going to be positive. Factors of 20, 1 and 20, 2 and 10, 4 and 5. We would want to do positive 4, negative 5 to add up to give us negative 1. So I would write 2x squared minus 5x plus 4x minus 10, right? Okay, but it's not x squared and x. I'm going to go over here and write what we actually have. So nothing is different. We did it just the same. But instead of writing 2x to the 4th minus x squared, the only thing I'm going to change, I'm going to rewrite 2x to the 4th. Now instead of negative x squared, I'm going to write negative 5x squared plus 4x squared. That was to replace this negative x squared. And then I still have minus 10. So I did everything just the same. All right, grouping these two and then those two. I can now pull out an x squared. I'm left with 2x squared minus 5. I can pull out a 2 and I'll be left with 2x squared minus 5. So this factors to 2x squared minus 5 times x squared plus 2. Okay, here we go. M squared minus 9mn plus 14n squared. I see m squared, n squared, mn. We've seen this before. Let's go get the numbers. 1 times 14, I've got 14 up top, negative 9 down below, so they're both going to be negative. Factors of 14, 1 and 14, 2 and 7. Negative 2 minus 7 gives me negative 9. Okay, since the leading coefficient is a 1, I've got my factors. M minus 2, m minus 7. Since we have the n squared, don't forget to put the n's in the factors. M minus 2n times m minus 7n. Number 11, I'm going to factor out the GCF first. I see a y cubed can come out. If I factor out a y cubed, that'll be squared, that'll be to the 1, that'll be gone. I'll have left y squared minus 8 or plus 8y plus 12. Now to factor the y squared plus 8y plus 12. I want 12 in the top, 8 on the bottom. They're both going to be positive. 1 and 12, 2 and 6, 3 and 4, plus 2 plus 6 gives me 8. Okay, I have y cubed, y plus 2, y plus 6. Last question, question 12. Roland sells cases for smartphones online. He noticed that for every dollar he discounts the price, he sells 2 more cases per week. His income is given by this polynomial, negative 5d squared plus 35d plus 390, where d is the dollar amount of discount in price. Calculate his income if the discount is $3. So we're going to plug 3 in wherever we see d. I'm going to go do that on my calculator. Negative 5 times 3 squared plus 35 times 3 plus 390. When d is 3, his income will be $450. And now it wants us to write that polynomial in factored form. Okay, we want to write it in factored form. First thing I need to do is factor out a negative 5, because that's the GCF. I'll be left with d squared minus 7d minus 390 divided by 5 is 78. Okay, can I factor d squared minus 7d minus 78? Up top, the number is negative 78. On the bottom, the number is negative 7. Because the top number is negative, the signs are going to be opposite. Factors of 78. 1 and 78, 2 and 39, 3 and 26. Will 4 go into it? Nope. 5 won't go into it. How about 6? Yep. 6 and 13. That's it. That's what we need. Okay, I'm going to do positive 6 minus 13 gives me minus 7. So positive 6, negative 13. When I add those two numbers, I get negative 7. Because it's a 1 out front of the d squared, I don't have to factor by grouping. I know that I have negative 5 times d minus 13 times d plus 6. So this is what goes right there. Okay, evaluating the factored form. What if I plug in 3 for d? I'm going to plug 3 in for d, so I'm going to do negative 5, 3 minus 13, 3 plus 6. Here we go. Negative 5, 3 minus 13, 3 plus 6. I get 450. The result is 450, and it's the same as part A. I also got the number 450.